the next part of translation of functions that we're going to look at reflections and dilations. And these are the ones that I think take a little bit more practice. And some of you guys might be really good. It's a reflection over x, y. And we're going to talk about that, and then we're going to talk about a different way that we can think about it as well. So for example, reflections. That's if we have negative f of x, or we might have f of negative x. So you can see here that it's affecting your entire thing. I always think about this as like the opposite of y. And some of you might see that negative and say, oh, it's a reflection over the y-axis. I think this is the opposite y value. So what is that really a reflection of? So if I have an opposite y value, it would move down here. So this is a reflection over the x-axis. Whereas if we have something that says the opposite of x, let's say that's here, opposite x would go to negative. So this one is a reflection over the y-axis. So if we were to take a look at a problem here, let's say I asked you to describe how does we have an absolute value, but we have a negative here. Now I see how that's the negative is on the outside. So if I scroll back up, that's similar to this one right here. It's on the outside. So to myself, when I see this, I think it's the opposite, oops, can't spell there, opposite y value, and then it moves it up 3. So then I start thinking opposite y value. So again, I always think opposite y from here to here. So that reflects over the x. Whereas if we would have had this is saying the opposite x value, which is the other way. So opposite x would be from here to here. So reflect over y. And then we're still moving up 3. Now for dilations, and these are sometimes, this is the one I always have to refer back to notes on. Dilations mean something's getting like wider or narrower or taller or shorter. So there's two ways that dilations are with a number. So that's like f of ax, or your a might be on the outside. So again, I think of, is it directly affecting the x or is it directly affecting the y? So this one here, it affects the x value, which in terms it's going to change the shape of your graph in general. But if I'm thinking distinctly what that means, it's affecting your x. And x's are always opposite by a scale factor of 1 over that a value. A times f of x, this affects the y. And it's by a scale factor, I'm going to abbreviate that, of a. So if we have an example here, let's say we have f of x equals 1/3 x squared. So for example, if we had to graph this, we know a basic parabola, 0, 0, 1, 1, 1, 1, 2, 4, negative 2, 4. So this affects the x by a scale factor of 1 over 1/3, which is really 1 times 3 over 1. So by a scale factor of 3. So this is going to get 3 wider. So this is the coordinate 1, 1. 1, 1, 2, 3. It's really going to go to 3, 1. And this one was 2, 4. It's really going to go to 2, 3, 4, 5, 6, which is totally not going to fit on this graph, 2, 6, 4. So it's going to make it wider. So it's kind of the opposite. You see that 1/3, you think it's going to get narrower, your x values will go in, but x is the opposite. Now these ones, we're going to take a look at, what we see on Delta Math with these, because these are another one where you're going to have to be like, okay, this is getting close enough here. So let me see if it was this part of it. So this one here, let's take a look. This says the opposite x values. So I'm going to take one of these blue ones and I'm going to look at that coordinate. It's 1, 1. So it would become -1, 1. So this one, it looks like it's actually the exact same. And it is, because that is symmetrical to the y-axis. So if we take a look at this one, opposite, it's outside, it's not in parentheses, so that's the opposite y value. So 1, 1, and this is where sometimes mine get off here. I'm going to flip it to -1, 1. So you can pick a coordinate here and try and switch it. So some of these are basic ones here. Okay, let me grab a different one here. So for example, this one, and these are where they get tricky. Half x. So in our notes, we said half x, it's the opposite. So we're gonna double our x value and move it up 1. So I'm gonna go to this coordinate right here, 1, 1. I double the x, so it becomes 2. And then I need to move it up 1. And we'll see how this works. This is where sometimes, you can see I got it wrong again, but it's pretty close. I just got it, I should have moved this other one. So maybe next time I'll try moving these 2 coordinates here, because that other one obviously didn't get moved in the correct spot. And I think a clue to this might be when you're doing like a whole thing up 3, use the green dot. But we always do those reflections and dilations first. So opposite, it's on the outside, so that's the opposite y value. So I'm going to look at these heights, so it's 1, 2, and 3. So if I move this down, it should be at -1, -2, and -3. Okay, so that looks good for the opposite. 1/4 x. So it's directly affecting our x, so that's going to be times 4. So 1 would go to 4. And then up 3, I can't move any on. So if you're moving the whole thing, we'll move that button there. And let's see how close we get. So you can see that one worked. So let's take a look at one more here. And this is, so the opposite here, opposite's on the outside, so that's our opposite y value. So I flipped that because it wasn't, and you can always click this start over. So +1 goes to -1. 8x. So again, our scale factor, since it's next to x, it's going to be 1/8. So this is at 1, so it's got to go to 1/8. If I look at 8, that's got to go to 1/8. 8 times 1/8 is 1. So this has to back up to here and then up 5. And let's see what it says for that one. So you can see again, I got it wrong, but it was pretty close. I just didn't take another coordinate here. So if it looks like this, you have the general idea, and that one is close enough there.